Okay, welcome back to the channel. It's been a little while since we've done an engine build in the shop. Today we're gonna start a quick and easy 3-part series of me building the 408 LS that I ran in my red C5 Corvette at the Texas Mile. So here's the engine completely stripped down. I was running a Gen 4 6.0 iron engine block with our Smedding 4-inch stroke 4340 forged crankshaft. I also had a set of aftermarket H-beam rods that were not Smeddings and a set of the Wiseco Summit brand LS pistons. But today we're going to intro part 1 of this video series, which is going to be a full machining breakdown on the engine block. So we're going to CNC parallel surface it, we're going to CNC hone it to size for the new pistons, and we're going to balance my Smedding crank for the new rotating assembly, which is our Smedding 1,300 horsepower rated rotating kit. This is a really nice rotating kit. It comes with, of course, the 4340 forged crank. I'm going to reuse the crank I had. I ditched the old rods because we now have our own Smedding Power Adder H-beam connecting rod. Comes in this really trick box. You got 4 right there, and then the other 4 underneath it. And let me get these guys unpackaged real quick and show them to you. Okay, so here's our Power Adder connecting rod. We've got a little extra mass around the bolts to help at real high RPM. And although the beam looks fairly thin compared to a standard H-beam, it's very thick in the middle. This is still a heavier Power Adder rod. And of course, it comes standard with some ARP 2000 Smedding hardware. Yeah, we have our own bolts now. So that's the connecting rod we're gonna use in our 1,300 horsepower rotating kit. And then here are the pistons. Our 1,300 horsepower rotating kit comes with a set of Icon Premium 2618 pistons. These are a sweet bargain deal, guys. It's a 2618 aluminum alloy, has coated skirts. It has the thermal barrier on top for Power Adder applications. It comes with a set of trimmed 180 wall thick chromoly wrist pins, all nicely boxed up. And the rings, I haven't unboxed the rings yet, but it comes with, here we go, stainless steel top, Napier hook ductile iron second, and 3mm oil, 1.2, 1.2, 3.0. These are a Hastings ring pack, and we actually use these in all of our LS engines, and they are awesome. This ring pack compared to a standard like Total Seal 16th, 16th, 3/16 is about 20 horsepower. We literally tested it a couple weeks ago. So anyways, that's what we're doing on the rotating side of things. We're gonna get all this over to our crankshaft balancing station. We're gonna weigh the components to get a bob weight, and then we're gonna get this crankshaft balanced, and then we'll move on to block machining. Okay, now the crankshaft is on the balancer. We have our bob weights attached to the crank, which simulate the rotating weight of the rotating assembly, the rods, the pistons, the rings, the wrist pins. And now we can give it a spin. We're gonna let it spin up, and our computer screen is gonna show us exactly how much weight to remove and where to remove it. So, looks like it's spinning and measuring. Okay, looks like we have 15 grams to take out of the rear and 16 grams to take out of the front. This new rotating kit is a little bit lighter than the old one I used to run, which is a great thing. The piston design is a little nicer, the rod design is a little more efficient. So we're gonna get it drilled really quick, and then this guy will be done and ready to go into the new combo. All right, the crankshaft is now fully balanced. We're about a gram front and rear. That's a solid 12,000 RPM balance job. Now let's throw the block in the Haas CNC machine and let's deck it. The engine block is now in our Haas VF6 CNC machine. We have it in a truing fixture, so the block is actually located off of the cam tunnel and the main tunnel for the crankshaft. And it then locks it at exactly a 90-degree angle so we can make perfect 90-degree passes on our machine, on our block. This way the whole block can get paralleled. All the deck heights will be the same in all 8 cylinders. And really nice setup. So I'm gonna throw you guys in there on a tripod and we'll do some more time lapse showing this block getting decked. Now we have the 6.0 engine block in our Rottler H80 CNC cylinder hone. The first thing we're going to do is chase out all of the head bolt threads so that there's no debris or contaminants on those threads when we go to install the studs so we can install torque plates. So ARP sells a LS specific thread chaser for stock blocks. I just put it in a drill with the clutch turned on in case it hits something too hard. And I'm just gonna run it through all the holes on both sides, and then I'll take an air gun, blow everything out, and then I can install the studs so we can install the torque plate. So you can see it did pick up just a little bit of some iron rust, some little metal debris, some leftover assembly lube or thread lubricant. So now all the studs are clean. Let's come back and blow it off with air. Okay, this side is torqued down, the torque plate has been installed. Again, this is to simulate a cylinder head being torqued to the engine block. All of these fasteners, when they're final torqued, are gonna put different stresses through the block. This can change the roundness of the cylinder bores, so by simulating the head, we can hone the cylinder perfectly straight when the block is stressed. That way when the head gets torqued on when it's being built, everything goes straight again. Now we're gonna do the same process on this side, again with the head gasket we're gonna run, and then we'll be ready to start honing. We are now ready to start honing. We're going to do a two-step plateau hone on this engine block since it will be a power adder combo. So we're going to start with a very coarse equivalent to about 180 grit diamond. That's going to cut a coarse finish. We're going to take it to final size with these stones, and then we'll come back with this 600 grit equivalent plateau diamond, and that will give it a nice polished finish for the rings. The reason we want to do that on a power adder engine is because power adder engines obviously make a lot more cylinder pressure and they make a lot more cylinder heat. And we want to keep the piston rings cool so that they don't burn up too quickly. So in order to do that, we can cut into the block a deeper valley with this coarser stone. That valley will hold more oil to help lubricate and cool off the rings. Then we'll come back with the 600 grit polishers and we're just going to knock off the peaks. Then we're left with a very smooth finish for the piston rings to glide on and seal against, but we have those deep valleys to help retain oil. So first we're going to knock 1/1000 out of the engine block. I start with 1/1000 just so I can then come back and check how straight we're honing. We'll make any adjustments if we need to, and then we'll go to final size. We also hone in this pattern. We don't go hole to hole to hole to hole. We skip holes around because we don't want a little bit of friction and heat generated in one hole to thermally distort the hole next to it. So we're gonna jump. By the time we finish that hole and come back here, the theory is this bridge has cooled off and relaxed and we can hone it nice and straight. The 6.0 is now final honed to 4.010. Now we're going to take off the now we're going to take off the torque plates, we'll pull the studs out, and we'll deburr the top of the cylinder and the bottoms of the cylinders, so that way the pistons don't get beat up at bottom dead center or when we go to install them. We want to deburr the top because right now we have a really sharp edge from being surfaced and honed. So we want to create a sort of bevel so that when we go to install the piston rings can glide in nice and smooth and not get scratched up. And then of course we want to knock the burrs off the bottom of the bore so that when the piston comes down to bottom dead center and has a tiny bit of rock, it doesn't get scratched or scuffed when it gets pushed back up into the bore. To deburr the bottoms of the cylinders, I like to just use a simple hand burr, and then you can just real quick come in the bottom and do a quick ring around them. And there we go. We're going to throw this block in the jet wash now, get it nice and cleaned, and we can throw a paint job on it, and it's ready for assembly. The engine block has now been fully CNC machined. It's been parallel surfaced as well as plateau honed to 4.010 with dual torque plates. Cylinders have been deburred top and bottom. The block has already been stroker clearanced, but normally I would also say it's been stroker clearanced, and it has a fresh coat of paint on it. In the next video in this series, we're going to check bearing clearance, piston ring gap, and then assemble the short block on this 400 cubic inch nitrous LS engine. Thanks for watching, and I'll see you next time.